Section 9.2a is about factoring using the distributive property. I want to go back to Chapter 8 and examine the distributive property for what we're going to work on today. If you remember, we have something that's outside of parentheses and we multiply it. We're going to distribute that. It's called 15x squared plus 12x. That's the distributive property we've already learned. Now I'd like to look at the distributive property in reverse. I'd like to take that 15x squared plus 12x and apply this GCF idea that we've learned. If you look at these two terms, 15x squared and 12x, what is the greatest common factor? Well, the biggest number that goes into 12 and 15 is 3, and the biggest letter that goes into x and x squared is x. So I'm going to take this GCF and I'm going to pull it out. I'm going to remove that factor from each one of these terms. Then you have to ask yourself, 3x times what gives me 15x squared? And the answer is 5x. So I've removed the 3x from the 5x that would together give me 15x squared. And then 3x times what would give me 12x? The answer is 4. So you see that we can take a factor that's in common to each term and actually pull it out, or do the distributive property in reverse. This is called factoring. Factoring is when you take a polynomial and you write it in its completely factored form. That means all the factors that make up that polynomial with no exponents. Here I'm asked to use the distributive property to factor these. So I've got to figure out what factor will go into 15x and 25x squared. The smallest number that goes in is 5, and the largest number that goes into both is 5, and the largest number that goes into both letters is x. So that's my GCF, which means I'm going to take that GCF out and figure out what would be left if I factored it out. 5x times what is 15x? And the answer is 3. So if I left a 3 behind, that means I could pull the 5x out. And then if I pull the 5x out of 25, I'm left with another 5x. That's factoring out using the distributive property. Same thing on this one, except now we have a trinomial, so we have to find the GCF of all three terms. If you can't do that in your head, you could certainly make factor trees and find the GCF that way. The biggest number that goes into 12, 24, and 30 is 6. And there's an x in all three of them, and it looks like a y. So there's my GCF. So I'm going to factor out a 6xy, leaving what? Well, leaving a 2 here, because 2 times 6xy is 12y. Leaving a 4 and a y here, because 4 times 6 is 24. The x was already out, and then I pulled one of the y's out, leaving one of them behind. And then here minus 5xy cubed, because negative 5 and 6 is negative 30. I pulled one of the x's out, leaving one behind, and I pulled one y out, leaving 3 behind. That's how you factor using the distributive property. Here we'll learn about a special method of factoring called factoring by grouping. And you use this method when you have 4 terms that you're trying to factor. And what you do is you group them into pairs and factor those pairs individually. So here we have a 4-term polynomial, and we will group it. Make sure when you group it that you include the sign right here that's in the middle with the number that it goes with, because that sign is important. Now let's look at the first group, 4ab and 8b, and we'll factor out a GCF of 4b. When I do that, what's left behind? An a plus a 2, because 2 times 4b would give me 8b. Remembering that factors are things that are being multiplied. In the second group, what do I take out? A positive 3, and what's left? An a plus 2. Now the key with factoring is realizing that these two binomials have to match. If they don't match, then you're going to have to do something to make them match, because they have to match if we're going to use this grouping method. Now because they match, this becomes my new GCF. That means I take both of those and I pull them out to the front. So that means I'm going to factor out an a plus 2. Now the question is, after I factor out the a plus 2, what's left behind? Well, the answer, and I'll put this in green, is 4b plus 3. And then this would be my factored solution, a plus 2 times 4b plus 3. That means if I multiply those two binomials together and I FOIL them, I'll get my original 4-term polynomial. Here we have to factor. There are 4 terms, so we'll use grouping. Notice in my grouping I include that negative with the 2. Now what's my GCF here? It looks like an x, which means if I pull an x out I'm left with a 2y plus 7. And here it appears that there's nothing in common. So typically we would say a positive 1 is what we want to pull out. Now don't write that down, because you're going to notice hopefully something. When you pull a positive 1 out, these two groups don't match. And remember I said that they have to match. So what could I take out of here to make it a positive 2y, and what could I take out of here to make it a positive 7? The answer is I'm going to take out a negative 1, not just a positive 1. So I'm going to remove the negative, meaning I'll leave behind a positive 2y and a positive 7. Now because these two groups match, I'm going to pull those out as my new GCF, 2y plus 7, and what's going to be left? An x minus 1. Here's another factoring by grouping. GCF of the first group is 5x. When I pull 5x out, I'm left with a 7 here, minus a y. In the second group, if I pull a 3 out, a positive 3, I'm left with a y minus 7. Remember we talked about these two groups in parentheses have to match. In this case, they don't match. But if you notice, they're very close. In the first one, the y is negative. In the second one, the y is positive. In the first one, the 7 is positive, and in the second one, it's negative. So they're off by a factor of 1. So watch what I'm going to do. I'm going to take a negative 1, and I'm going to pull a negative 1 out of this first one. I'm going to take an additional factor out. By pulling the negative out, I make the y a positive, and I make the 7 a negative. Now let's see what that does for us. By pulling this negative 1 out, I'm able to change the sign of both of those, and then I just rewrote it so that it matched this one in the back. Now I get two groups that match, and I can pull those out as my new GCF. Now what am I going to be left with? Well, I'm going to be left with a negative 5x plus 3. This idea of pulling out a negative value right here, removing a negative value from this polynomial, is an important one in grouping, because sometimes you need to do that to make these two binomials match. Here's our last factoring by grouping. We'll group them and take out a 4 in the first group, leaving a b minus 5 behind. Now in the second group, I'm going to take out a 3 and an a. But if you notice, if I take out a 3 and an a, I'm going to be left with a 5 here in the front, and I'm going to be left with a minus b. That won't work because these two groups don't match. So what I'm going to do instead is take out a negative 3a, and that way I can leave this b as a positive b, put it in front, and then make this 5 a minus 5. So b minus 5 comes out, factors out, and I'm left with 4 minus 3a.